Astronomers have detected a superluminous supernova from a massive progenitor star. Based on information that has been presented, stars that are greater than about 8 solar masses end their lives spectacularly as a supernova. These single-star supernovae are called core collapse supernovae because their dense cores are composed primarily of iron, and at this late stage of their lives, they are no longer able to withstand the inward pressure of gravity, and they collapse before exploding. The core collapse of a supernova that displays strong atomic hydrogen emission lines are thought to result from the explosions of red supergiant stars. These are massive stars that have evolved beyond their principal hydrogen burning stage and would have had an extended radius. Until recently, however, astronomers thought that these stars were relatively quiescent until their final demise, but evidence presented has shown that they actually experience strong mass loss before the explosion. In some computer models, additional radiation is emitted when ejected from the supernova encounter. These mass loss envelopes in shocks, and variations in this process are currently responsible for the observed differences in the emission from core collapse supernovae. Over the last 10 years, a new subclass of supernovae has been identified. These have been called superluminous supernovae, or SLSNEs. They can be as much as 10 times as luminous as usual supernovae at their peak and fall roughly into two groups, depending on whether they have strong or weak hydrogen emissions. Some strong or weak hydrogen emissions from some of these hydrogen-rich SLSNE indicate no signs of shocked emission from an envelope, however, adding to the complexity of what has been presented. Supernovae are key cosmological measurements because they are so bright and can be seen shining in the early days of the universe. The most distant supernova so far dates from an epoch only about 3 billion years after the universe started. The distances are reliably determined by comparing the measured and intrinsic luminosities, but only when the intrinsic luminosities are accurately modeled. Astronomers are therefore working to account for all of the various classes and subclasses of supernovas. Based on information that has been presented, it seems there's an ongoing project titled the Automated Survey for Supernovae. It consists of 24 telescopes across the world, which automatically survey the visible sky for supernovae. The team, following up on one source, concludes that it is a rare luminous hydrogen-rich supernova, but with no evidence of ejector interacting with an envelope. The scientists and researchers conclude that the star must have had only a modest wind, only about 2 10,000ths of a solar mass per year. Some X-ray measurements suggest that it could have been even smaller. The researchers estimate that the progenitor star probably had a mass of between 19 and 26 solar masses. Supernova is the largest explosion that humans have ever seen. Each blast is the extremely bright, super powerful explosion of a star. A supernova is the largest explosion that humans have ever witnessed. Each blast represents an extremely bright, super powerful explosion of a star. One type of supernova is caused by the last hurrah of a dying massive star. This occurs when a star at least 5 times the mass of our Sun goes out with a fantastic bang. Massive stars burn huge amounts of nuclear fuel at their cores or centers. They produce tons of energy so that the center gets extremely hot. Heat generates pressure, and the pressure created by a star's nuclear burning also keeps that star from collapsing. A star is in balance between two opposite forces. The star's gravity tries to squeeze the star into the smallest, tightest ball possible. The nuclear fuel burning in the star's core creates a strong outward pressure. This outward pressure resists the inward squeeze of gravity. When a massive star runs out of fuel, it cools off. This causes the pressure to drop, gravity eventually wins, and the star suddenly collapses. A star 1 million times the mass of Earth, collapsing in 15 seconds, will produce a huge explosion. The collapse happens so quickly that it creates enormous shock waves that cause the outer part of the star to explode. Usually, an extremely dense core is left behind, along with an expanding cloud of hot gas called a nebula. A supernova of a star more than about 10 times the size of our Sun may leave behind the densest objects in the universe, known as black holes. Like, comment, share, and subscribe. Let me know what you think about this fascinating discovery of this super luminous supernova. Thanks for watching, and goodbye.